Hi there, it's lesson 92 time. Simplifying complex fractions. That's the lesson for today. We were working with fractions, with polynomials and fractions and stuff back in lesson 88, so we're going to kind of amp it up today. There will be variables and whatnot in our stuff, but we're going to investigate really weird fractions. In fact, they're so weird they're called complex. Complex, that doesn't sound easy, it sounds complicated, but here's what we got. Ignore me, ignore this. Up here, one fraction containing one or more fractions in the numerator or the denominator. We got several different weird ones here, and I'll write in some numbers so that you can imagine what this actually means. A fraction divided by a whole number. So maybe it's 2/3 divided into 4 pieces. That's kind of weird, right? Or maybe it's 2 over x divided by y. That's a complex fraction, and we want to simplify that. Or maybe a whole number divided by a fraction, like 3 divided by 3/5. 3 divided into 3/5 pieces. That's kind of weird. Or maybe 3x divided by 2 over y. That's with variables. Okay, or the granddaddy of them all, a fraction divided by another fraction, like 2/3 over 4/5. It's kind of hard to get an idea of what that actually is or what it would mean, or maybe a word problem with those things in there. Nevertheless, there are some quick tricks that we can do with all of these to help simplify things. I think one thing you can do over here on these ones where you got like a fraction divided by a whole number is to imagine that whole number does have a denominator of 1. Okay, for me that's going to actually be kind of helpful. Here, the same thing. I think if we imagine that up here is also divided by 1, like it has a denominator, a numerator denominator, that'll help because this one right here is kind of, to me, the key of fixing these types of problems. Now, we could go back and look at what this actually means when you divide one thing by another. If we were to pull this thing apart and say, well, you got this fraction, and write it sideways rather than vertically and say divided by c over d, I think we have a better idea of what we're supposed to do. Because anytime we have with fractions, division of a fraction, we are supposed to multiply, and then instead of c over d, we take its inverse. So dividing by c over d is the same thing as multiplying by d over c. Once we get there, fraction multiplication is pretty simple. We multiply straight across a times d and b times c. So that's where we end up, right? That's where we end up is this is equivalent to that, and that is on your reference sheet for algebra. Okay, so this is the end goal. And we did it this way by writing it sideways rather than vertically. But what else we could do with this one is we could say, well, if we multiply both the top and the bottom by the same thing, and a smart thing to do here would be to multiply it by this thing's reciprocal so that the c's cancel out and the d's cancel out. And if I do that on the bottom and all that makes 1, I also have to do it to the top. Look what I get, right? I get a times d over b times c. A and d and b and c might be more complicated, like it might be an x plus 2 or it might be a 2yx, but that's okay. The same exact generalization applies. The quickest way to look at it is that you're going to take the numerator and the bottom denominator, and those two you can see become the answer to the numerator of our t time. B and c, those two go together down here. So you take the extremes and the means. That's what I like to talk about. Top and the bottom numbers go together. The middle numbers or variables or whatever expression gets sandwiched down there. This is super duper key because we're just going to apply this rule over and over again as we do the next set of examples. So let me throw some up there on the board. I'll get this cleared out, but make sure that you've got this down. all these ones then turn into these types of problems if I make it 4 things here, a fraction divided by a fraction, and then we'll proceed from there. Now work on the snowflake question first here. Number 1, fraction over a fraction, a fraction, a complex fraction. And I'm going to use that rule over there, that I'm going to multiply by the reciprocal. Or I can just take A, B, C, D and say, well, the top thing times the bottom thing divided by the middle sandwich pieces, B times X. You can leave it like that. It's cool. Or you do a little bit of distribution, A squared plus AX over BX. No canceling necessary. Either of those two are acceptable setups. See how fast that was? I just was like, these get multiplied, they go on the top. These get multiplied, they go on the bottom. Bam, just like that. We're able to use the reciprocal here because fractions are division problems. We're dividing AX by B over A plus X. Division of a division problem is multiplication. Take the next one here. We got A, B, C, D, right? We got the same setup. A fraction divided by another fraction. And so I'm going to take the reciprocal of that one and multiply it. Or I'm going to take the top and the bottom ones and multiply them together. A, M, and M, N. Divide that by the middle junk in the sandwich, N times X. Gotta clean this up a little bit because I got an A, I have 2 M's and an N. Down here I have an N that's going to cancel out and an X. So that's all that I'm left with, QED. This is pretty fun, isn't it? Well, let's do some more. Let me point out to you something I put down there in a little box. You're probably wondering where this came from and why in the heck I've left it there and all that kind of stuff. Let me talk about this. Every now and then, you get a super extra surprise, and that is, you get a fraction and another fraction, but both fractions have the same denominator. For instance, if you had 3/4 divided by 1/4, when you do the math and you flip it over, you get this, and those 4's cancel out, and all you're left with is the 3 over 1. So remember, the original thing here was 1/4. If they were both fourths, we basically can do this and be left with that 3 and that 1 there, as you can see here. They both had a denominator of B. I can just take that out of the way and have A over C left over. And you go, yeah, sweet. The reason why I bring that up is because these look very similar to each other, and that if I did a little bit of factoring, I'd actually have that factor in both things. So I'm kind of preempting, kind of priming the pump here because I know where this question is going. Factor a little bit, simplify first, and then do this process over here with the A, B, C, D business. So that can't be factored, but this can because there's a factor of 6 in each term there. It leaves me with an X plus 2. And then down here, I've got a 9 and an X plus 2. Now look at this. That can be simplified a little bit, can it not? I've got a factor of 3 and a 6, so I can call this a 1 over 2. I'm going to erase that and clean it up a little bit right now in here. X and this. Okay? Now I'm going to apply the whole thing there, but I've got X plus 2 in both the denominators. I know by that rule over there, that part's going to cancel out. But I'll go ahead and multiply this one by its reciprocal. Okay, if I was honest here, I do this, and then all that cancels out. And I do it again up here, and lo and behold, I would get X plus 2. And down here, I get 9 and 2 makes 18, and X plus 2. These are factors. This is multiplication and division, which means that can happen now. That's equal to 1. And I'm left with a simple numerator-denominator problem. I could have stopped right here, and I could have said those are going to go away and had X over 2 over 9. And that would have turned into x over 2 times 1 over 9, and save myself some ink and some oxygen and about 3 other things. So that's kind of a neat trick, but you're really not going to see it unless you can see ahead. But factoring first on this piece right here would be a good idea because it'll clean up a lot of other things on down the line. I think maybe they wrote it like that for that reason. Two more. Combining fractions to simplify in an application and teach you how to speed walk. Right out. Here we go. This one's a little weird because we don't just have a numerator and denominator down here. We have like a mini problem. So what we're going to do to simplify this is we're going to ignore that because that's already kind of pretty cleared up, and we're going to work this one right here. I'm going to take this out separately and say we got to have this as just being a numerator-denominator problem. So I need a common denominator. X is the least common factor. I got to multiply this one by x over x in order to be able to combine these two. This one turns into x minus 1, and both of those things are over x. That's better than this because it has a numerator-denominator. Okay? So we take that mini problem, we fix it, and then we're going to replace it with what it's equivalent to. We do this 2 ways now, but maybe you see what I see. Do you see what I see? I'm going to go ahead and do it the long way, which would be 1 over x times x over x minus 1. I get x over x minus 1. The x's cancel out. I'm left with 1 over x minus 1. Okay, use the reciprocal. Or I could have noticed, hey, folks, it's got the same denominator. The x's are going to cancel out when I do that. I'm just going to take care of that right now and have left over 1 in the numerator and x minus 1 in the denominator. That was pretty sweet. I'm sure glad I knew about that. Sure glad you know about it. Aren't you glad you know about it? You should be. That was free. Well, sort of. Last example. Remember, pause, go back if you want to do that over again, see what in the world that I did, but could have done this right here too, and just seen what was left over. Example 5. Example 5 uses a setup where they've got some speed walkers, which is a ridiculous sport. Seen it in Salem. Olympic trials for speed walking minutes. And I got this other expression, 5x minus 20 over x cubed miles. And they want to compare these two things. And one of the tricks to this problem is to remember that a distance is equal to rate times time. D equals R times T. Or any variety there. If you want to solve for rate, you'd go distance over time, like miles per hour. If you want to solve for time, you divide distance by the rate. So for instance, 10 miles equals 5 miles per hour for 2 hours, right? Okay. So they want us to compare one to the other, and that would mean let's actually write it the way they would like it set up. 5x minus 20 over x cubed. You're comparing one fraction to another fraction, which means there's going to be some division. Did I get that right, or did I do it upside down? I did it upside down, doggone it. Here we go. Move that down there. 3x squared minus 12x over 3x. I think I'm going to leave that for you to think about, but there is definitely some factoring that needs to happen there before we do some combining. So simplify first and then do some combining. But let me just get this one started for you. That's not going to change, and that's not going to change, but I think the factoring is going to happen here, and it's going to happen here. So bring that one to class if you want to. I'll show you how to finish this one off. But I think you'll probably have a pretty good head start if you just follow the patterns that we've already established today.